Welcome to determining the formula of a compound. So we can use the mass percent to determine the chemical formula for an unknown compound. So suppose we want to determine the chemical formula of an unknown compound that contains carbon, hydrogen, and nitrogen. So if we know that when 0.1156 grams of the unknown reacts with XX oxygen to produce 0.1638 grams of CO2 and 0.1676 grams of water and some unknown quantity of nitrogen-containing compounds. So let's assume that all of the carbon present in the sample initially is converted to carbon dioxide. The mass fraction of carbon in carbon dioxide is given by this calculation. So the mass fraction is 12.01 grams of carbon divided by 44.01 grams of CO2, which means that the mass of carbon in our 0.1638 grams of carbon dioxide is given by this calculation. So we take our mass of carbon dioxide multiplied by the mass of carbon in carbon dioxide, which gives us 0.04470 grams of carbon. So this carbon was originally contained in our 0.1156 gram sample of unknown. So of that 0.1156 grams of unknown, 0.04470 grams of it was carbon. So now we can calculate the mass percent of carbon in the unknown. The mass of carbon divided by the total mass of the unknown, multiplied by 100%. So we know that our unknown was 38.67% carbon. So we can repeat this for hydrogen, assuming that all of the hydrogen present in the sample initially was converted to water. And that means that we end up with a mass fraction of hydrogen in water of 2.016 grams of hydrogen divided by 18.02 grams of water, which then means that the mass of hydrogen in our 0.1676 grams of water was given by this calculation. So we end up with 0.01875 grams of hydrogen. So this hydrogen was originally contained in our 0.1156 gram sample of our unknown, which means now we can go ahead and calculate the mass percent of hydrogen in our unknown. So we have 0.01875 grams of hydrogen divided by 0.1156 grams of our unknown multiplied by 100%. That gives us 16.22% hydrogen. And now our compound contains only carbon, hydrogen, and nitrogen. So the rest of the compound's mass is due to nitrogen. So the mass percent of nitrogen is 100% minus the 38.67% due to carbon and the 16.22% due to hydrogen, which gives us 45.11% nitrogen. So now we know the mass percent of each of the elements. I have them listed down here in this table, but we need to know the number of atoms of each element so we can write the formula. So let's assume that we have 100 grams of our unknown compound. We know that carbon is 38.67% of it. That means that carbon will be 38.67 grams. The hydrogen will be 16.22 grams, and the nitrogen will be 45.11 grams in that 100 gram sample. So that's what we have here. So now we know the mass of each element that we have in our sample. So now let's go ahead and calculate the number of moles of each element in our sample. So we have 38.67 grams of carbon divided by carbon's molar mass. That gives us 3.220 moles of carbon. We know the mass of hydrogen we have divided by the molar mass of hydrogen. That gives us 16.09 moles of hydrogen. We know the mass of nitrogen we have divided by the molar mass of nitrogen. That gives us 3.220 moles of nitrogen. Now, you note here that the number of moles of carbon and nitrogen are the same. That isn't always going to occur, but now we can find the smallest whole number ratio of atoms by dividing the number of moles of each element by the smallest of the three values. It doesn't matter whether we pick the moles of carbon or nitrogen. In this case, I've picked carbon, but you pick whichever the smallest number of moles is. So we take 3.220 moles of carbon divided by 3.220 moles of carbon, and we end up with 1 mole of carbon for every 1 mole of carbon. That's sort of a trivial result, but it is what it is. Then we end up with 16.09 moles of hydrogen divided by 3.220 moles of carbon. And that gives us 5 moles of hydrogen for every 1 mole of carbon. And for the nitrogen, of course, we end up with 1 mole of nitrogen for every 1 mole of carbon. So now we can write an empirical formula, which is the simplest positive integer ratio of atoms in a compound for our unknown. So the empirical formula is not necessarily the molecular formula, but the molecular formula will be some whole number ratio of the empirical formula. So it may be 1 times the empirical formula, in which case the molecular formula and empirical formula are the same, or it may be 2 or 3 or 4 or so on times the empirical formula. So our empirical formula for our unknown is CH5N, because for every 1 mole of carbon we had 5 moles of hydrogen and 1 mole of nitrogen. But it may be that there is more than 1 carbon atom in our compound. So we have to do some additional testing to see what the molecular formula is. So there's more than one possible molecular formula, which is the exact molecular formula of the compound. So we may have CH5N, we may have C2H10N2, we may have C3H15N3, we may have C4H20N4, and so on, C5H25N5, and so on. But it's probably one of those. So, in order to determine the true molecular formula, we need to know the molar mass of the compound. So we do some experiment, find out the molar mass of the compound. If it's 31.06 grams per mole, then we know that the first one, CH5N, was right. If the molar mass of our compound is 62.12 grams per mole, then we know the second one is right. If it's 93.18 grams per mole, then we know the third one is right. If it's 124.24 grams per mole, then we know the fourth one is right, and so on. So we need to know what the actual molar mass of our compound is. So that was determining the formula of a compound.